Have you ever searched a mobile phone or a book or any product for that matter on Amazon or Flipkart? The first thing that you will probably do is sort the results by price, by rating, or maybe by popularity and then choose what to buy, right? Sorting is a fundamental feature in any application dealing with data. In Java, there are multiple ways to sort, and one of the most powerful approaches is using streams. But how does it actually work? If you have never used the sorted method before, you might think sorting is just one simple operation. But what if you need to sort products by price in ascending order? What if you need to sort employees by salary and then by experience? So there are two parameters involved for sorting here. Or maybe sort names alphabetically while ignoring the case. These are the special cases for sorting. And Java Stream offers a clean and flexible way to achieve all of this with just a few lines of code. Isn't that amazing? We will be working with our real project-like structure, which we introduced in last video, which includes model classes, employee, department, and address. It includes repository layer having employee repository and department repository. There is a service layer which includes employee service and department service, which is actually used by the application. So you will see sorting in action just like in real world application. And you know what is the best part? You don't have to just watch, you can try it yourself. How? The complete code covered in this video is available on GitHub. You can find the link in the description. So clone the code and you can try it out yourself. So let's get started and jump into how sorting works in Stream. So in this video, we are going to see two major sorting strategies. One, which is a basic sorting or natural sorting, and second is a custom sorting or sorting using a comparator. So let's explore the first one, which is a basic sorting. So in Java, we use sorted method in streams to sort elements. I'm in stream operations demo class where we have a main method. So it is acting as our application, and for simplicity purpose, I have created a separate method called as basic sorting demo, in which we will write all the code for basic sorting. Going forward, we will see the custom sorting scenarios in this particular method, custom sorting demo, and we can simply call these methods from our main method in order to see the result. So let's get started with exploring how we can sort list of integers. For example, let's create a list of integers first. Two, 5, 1 and 3. These are the numbers which I have added in a list, and let's see how we can sort this given list. So what we need to do is we need to open a stream on this. So then I'm calling a sorted method. So if you see, there are two variations of sorted method: sorted with comparator and sorted without any argument. Sorted without any argument does the natural sorting. Okay, let's call this method first. We are not providing any argument. So this sorted is nothing but an intermediate operation. So let's take a glance at how sorted works. So basically, it checks if each of the element in the stream, is it comparable? Does it implement comparable? If no, then it throws class cast exception. If yes, then what it means is the class has capability to sort its elements. So it is able to naturally order the elements. It applies that natural order comparator and it sorts all the elements and forms a new stream. So if I just go into sorted, it returns a stream. What we can do is we can call for each method and we can simply print each element in the stream. So this is a terminal operation we are calling. So this sorted intermediate operation, it will execute. Let's just run the code and see what is the output of this. Okay, so 1, 2, 3, 5. Bingo! It has successfully sorted all these elements in ascending fashion, right? So by default, all the primitive types or box primitive types like numbers, which can be integers, doubles, longs, right? Even strings, these all are naturally sortable because they implement comparable interface. Let's try it with strings. Let's create list of strings. So let's say list of string, we can say names is equal to, again we create an array list, quickly add names, Okay, so I have given some inputs and let's see how this strings get sorted. So what I was saying is, if you go to string for that matter, you will see that it implements from the comparable interface. And what is comparable interface? Comparable interface provides a compare to method using which you can basically compare a particular class's object with its own type. So it provides that capability of comparison. So let's see what output we get if we call sorted method on this. And let's just do for each println method reference, and we are printing it. So again, if I run this, because it is a numeric, this element, it comes first in order, then followed by A because it starts with A, it starts with B, and very last it has one more character in this particular string, so it is at the last. That's how it has sorted naturally this. So we know that we have an employee class, so can we sort? Let's try to do it. Okay, so I know that I have employee service and there are many methods, list of employee by city or list of employee I can get with particular name as a substring. So I can call any of this method and get a list of employees. Let me pick this one, get by city. Where do we have employee service? It is declared at the class level. It is a static, so we can add in static context. We have a static method here. We are writing the code in. So employee service dot get by city, and what city I can provide is city Pune. So I'll get all the employees in city Pune, and I'm opening a stream on it, and I'm using sorted method as we have done for integer and string above, and simply I'm calling system.out.println. There should be no problem printing out an employee because we have overridden toString method here, so it will print the employee. So well, let's try out if this works. Okay. Oh, what has happened? It says class cast exception. And why? If you remember, we have seen a diagram which shows that if elements are not comparable, it throws class cast exception. And now you can guess that natural order comparison is not possible because our employee class does not implement from comparable interface. To be able to sort the employees naturally, we need to implement our employee class from comparable interface. So let's do it. Let's check how comparable is defined. It is a generic interface which takes a particular type. Our employee is a type which you want to compare, right? So it has a compare to method which we need to override. The editor itself suggests that implement methods compare to. Yes, I want to implement it. And employee O, I'll say other. So how do you want to compare? Usually what parameter I'll select is nothing but primary key of employee. So ID is something I'll use for comparison, right? I'll order my employees by employee ID. So how can I do that? Is, so I have a long class dot I can call compare method on it. What I can do, first parameter to it is this dot get ID, and second parameter is other dot get ID. Let me tell you how compare method of long class works. Numbers are naturally sorted in ascending manner, so the longs are also sorted in ascending manner. So if this or current employee's ID is less than that of other employee's ID, then long.compare method will return a negative value, and it indicates that this employee comes before other employee in sorted order. Then if both this and other employees are having the equal ID, then long.compare method will return 0, which indicates both employees are equal in terms of ordering. Case 3 would be if this or current employee's ID is greater than that of other employee's ID, then compare method of long class will return a positive value, which indicates that this employee comes after the other employee in sorted order. Well, now our employee class implements comparable interface, and now let's try to run the same code. So I'll go back to stream operations demo. Let's try to see output of this. Bingo. This time the class cast exception is gone because we are implementing from comparable interface. and you can see that they are sorted by ID, and that's what we wanted. So far we have seen how to sort either numbers, strings or custom objects with their natural sorting order, which is nothing but ascending. What if we need some custom sorting logic? Even in employee, we can't give multiple sorting logics, right? We can only sort employees internally by a single logic which you have provided by implementing compare to method. But what if you want to sort it descending, or you want to provide this logic externally? In that case, you have another variation of sorted method in streams which takes a comparator as input. Okay, comparator is another interface which allows external sorting or custom sorting, and you can basically sort objects with multiple sorting criteria. We will see how. So again, I'm going back to stream operations demo. Here we will see custom sorting demo, and here we will use our project structure and we will implement few methods in employee service, and we will test custom sorting. Fine, let's go to employee service, and you can see that I have created some methods over here. We saw that how to sort it using IDs. By now you will know how we can implement this particular method. We have already employee class which is sortable. You can just call a sorted method and return the result. First of all, you need to give call to employee repository, and you will see that there is a sort by ID method. And to complete the implementation, my service layer will always rely on repository layer, so I'm calling sort by ID method and I'm returning result as is from the service layer. Now let's go ahead and implement sort by ID method in repository class. I'm removing this to do, and I need to get employees objects. So I'm getting it from employee proxy. I'm opening a stream, and I can call sorted method, as we have already implemented our employee class by comparable. It will return another stream of sorted employees. We need to just convert it to list and return it back. So how to do that is collector and collectors.toList. So I'll go back to the stream operations demo. So what we can do is we can just call this method employee service dot sort by ID. This sort by ID will return us a list, and I'll just do for each, and I'll print all the elements which are sorted by ID. Okay, I'll just print out few things. Sorting by ID. Here what I can say is by ID in given city. Okay, let's see what is the output of this. Let's run, and you can see that sorting by ID, and it has sorted it by ID 1 2 3 4 5. This is all sorted. That's great. So we learned how natural order sorting works. Jumping to the next level of sorting, which is nothing but custom sorting. The thing that you need to do in custom sorting is call sorted method with a comparator. Let's see how that works. So let's scroll down, and you can see that I have also defined signature of this method, sort by experience. Okay, now I want to sort the employees by experience. I'll remove this to do, then I'll get employees. So database proxy dot get employees dot stream, right? And I'm calling sorted method, but this time with comparator. And how you can use comparator is comparator offers multiple static methods or factory methods in order to create comparators, and we can use comparator dot comparing method. And what comparing method does is, let's go into comparing method. It takes a function. There are two things out here. One thing is how you want to compare them. You have to provide that particular logic. I'll just go to this comparator. Comparing takes a key extractor. So you just want to define on which key you want to sort particular stream, right? So on which key we want to sort is nothing but experience. If you go to employee class, we have experience as a field, right? So on this experience we want to sort. So employee, let's say E. I'm writing a custom lambda which will extract the key. and we know that e dot get experience in years is nothing but that particular key extractor function. Okay, so I'm extracting experience and I'm saying that sort it using employees experience, and by default it is in ascending fashion, and I'm just collecting it to a list and returning it. What is the other way? You know that we can provide method reference as well. So if you just replace a particular lambda with method reference, it becomes more concise and shorter. So well, we have implemented the logic. Now let's test it. So in service layer, we have a sort by experience method. We'll implement it. We will just give a call, or we will just delegate to employee repository sort by experience. And now in this class, in the main method, what we will do, we will give call to the custom sorting demo. I'll just comment out method call. Fine. And here what we can do is, we have an employee service. We will call sort by experience. We just implemented it. It will return a list of employees, and let's just print all the employees which are sorted by experience. So you know the drill, just print them out and run the method to test the code. We'll just scroll to the lastly we have printed the experience in years for every employee. So 2, 3.3, 4, 4.55 and so on. So in ascending fashion, all the employees are sorted by their experience. That's cool, isn't it? Let's make it more interesting. So this sort by experience sorted it by experience in ascending fashion. If I want to sort it in descending fashion, so the exactly reverse of it is something I want to achieve. So first should be with experience 15, then experience 13.5 and so on. How we can do it? It is quite simple. Thanks to the comparators static methods, let's see how we can achieve it. Okay, let's go back to employee repository. I have created one more method which is alike, sort by experience descending. This time we will be sorting in descending fashion. Let's implement this method. I'm calling database proxy.getEmployees.stream.sorted, and we need to provide a comparator. So I'm calling comparing method. You can even provide comparing double, because experience is in double. So if I go back to the employee, experience is of type double, so I can actually call comparator.comparing double method as well. And we know, let's use a method reference employee, and we know the drill that we want employee experience. So get experience in years. Why is it erroring out? Is because of we are not returning a list. So bingo. But this is the exactly same implementation we have done above. Now what we will do is, this comparing double, if you see, it returns a comparator. So I can chain the further comparators to it. So what I can chain over here, so let's just beautify it so that you will understand it. Comparator.comparing double, and now I'm doing dot. There is a method called as reversed, which will basically reverse the comparison order, and this should satisfy our purpose. Let's run the code. Before running it, we need to call this method. Okay, so we have implemented it in repository. Let's implement. We have implemented it in service layer. We are calling the repository. Now let's call employee service dot sort by experience descending, and again for each system.out.println, and just to reduce some noise, I'll comment it out and we will directly run it. Yeah, bingo. See how simple it is. So these comparators are great. They offer us multiple ways of sorting. So far we have sorted by single attribute. What if I want to sort it by multiple attributes? So for that I have declared one more method, sort by experience and the skill count. So in employees, if you go and see, skills is nothing but a list. So let's say an employee whose experience is equal, let's say both employees are of 5 years experience, one possesses 4 skills, however other possesses 5 skills, we can basically compare them using the count of the skills. That's the purpose of this method, sort by experience and skill count. Okay, so do we have similar method here? Yes, we have. And what we are doing, we are calling sort by experience and skill count, which is nothing but this, and we will give the implementation. I'll remove the to do comment. Let's give the implementation over here. Database proxy.get employees. So I got all the employees and opening a string, calling the sorted method with comparator, and we need to provide a comparator. Now we know that comparator.comparing double, or you can provide comparing as well, because we know that experience is a double field, so we can call comparing double. I'm just collecting the result. So this part we saw, and we know that comparing double returns a comparator, so we can chain the methods. You can chain multiple comparators. So this is one comparator I have called. You can chain it with thenComparing. thenComparing method has multiple overrides. One accepts instance of a comparator itself, other accepting a key extractor function to determine what key you want to have for comparison. So the way I'll do it is employee e such that e.getSkills.size. So I want to count size of skills. So first preference will be the experience, and second preference for ordering will be number of skills that employee possesses. And you can chain as many methods as you want in this comparator. So fine, let's call it in our demo class. So I'll again comment this. Let's call employee service dot sort by experience and skill count, and then I'm calling for each. Let's run the code and see the result. So for this purpose, let's create some duplicate records. For example, okay, we will keep some employees with the same experience to see the result. I'm going into database proxy and I'm changing this data a bit. So let's say first two employees are of 3 years of experience, and what skills they have are different, right? So by skills we can basically just remember who are these employees: Rajesh and Shiven, ID 1 and 2. Okay, let's go back. We will run the method again, and we want to see 1 and 2, ID 1 and 2, Rajesh and Shiven. And you can see that both of them are having the same experience, but skills, if you just see, employee with ID 1 is having these 3 skills, whereas employee with ID 2 is having more than 3 skills, right? So if you reverse, you will see that this position will be reversed. Okay, so if I just try to reverse it, how you can do it, now you will understand that it is quite simple. Here we are declaring comparator, so just say reversed, so that the order will be reversed. Okay, let's focus on employee 1 and 2. So 2 comes first because there are more skills now. Okay, so this is in descending fashion. The normal was ascending fashion, which we just saw earlier. Yeah, so isn't that amazing that we have full control over how we can define the sorting order in streams? Just you need to remember some performance considerations when to use sorted. First point is, when you are sorting large datasets in memory, it can be slow for huge collections. So in real projects, consider sorting on database level instead of sorting in memory. For parallel processing, use parallel stream consciously, since sorting may not always be efficient in multi-threaded environment. It can hamper performance. You need to know these points when you are using sorted method. Today we explored various ways to sort Java streams, from basic sorting to custom comparators. Sorting is a critical feature in real world applications, and now you know how to do it effectively in Java. If you want to try out the code yourself, complete implementation is available on GitHub. Check out the link in the description. So don't forget to comment which sorting method do you use most often.
And if you found this useful, don't forget to like, share, and subscribe for more Java content. See you in the next video. Bye bye.